Today we are doing lesson 15.4, surface area and volumes of similar solids. This is the last lesson in chapter 15. Our I can statements for today: I can identify similar solids. I can use properties of similar solids to find missing measures. And I can understand the relationship between surface areas of similar solids and volumes of similar solids. All right, so we looked earlier in the year at similar figures, especially similar triangles, and we learned that similar means same shape but different side. We looked at two-dimensional figures, but the same is true for three-dimensional figures like these cylinders as well. If they are similar, they are the same shape but different sizes. And just like with the two-dimensional shapes, their side lengths will also be proportional. The ratios will be proportional. So for our first type of problem, they're going to give us some different options for cylinders, and they want you to pick which cylinder is similar to cylinder A. So we're going to write a ratio of sides, and we're going to see which two sets of sides are proportional. Okay, so I'm going to write it so that I have the radius on top and the height on the bottom, although it doesn't really matter. I could flip-flop it if I wanted to. Cylinder B is 5/3. Cylinder A is 6/4. And cylinder C is 7.5/5. When we looked at proportional ratios at lots of different ways to compare them. You can set them up and do cross products. You can look at simplified fractions. You can change them into decimals. I think I'm going to do decimals on this one, but you could do any way you want. But we need to see which two have the ratio of the sides be the same thing. All right, so 5 divided by 3, and you can use a calculator if you'd like to, gives me 1 6/10 repeating. If I do 6 divided by 4, I get 1.5. And then when I do 7.5 divided by 5, I also get 1.5. So which cylinder is similar to cylinder A? Well, that's cylinder C, because 7.5/5 as a ratio means the same thing as 6/4. Okay, our next type of problem is using proportions to help us find missing information. So here the cones are similar. Find the missing slant height L. That cursive L is usually what is the variable that's used for slant height. The letter H implies regular height, which is from the center straight down to the middle for a cone. Slant height is on the side. Okay, so we are going to set up and solve a proportion. I'm going to start with my cone X numbers. I'm going to put the slant height on the top and the radius on the bottom, 13/5. And then here I don't know what the slant height is. And then the radius is 7. Now I could have flip-flopped it if I wanted to. No matter how you write your proportion, that slant height and the 5 need to be diagonal from each other. Otherwise, you did not set it up correctly. So I put my slant heights on the top. I put my radiuses on the bottom. All right, there are no easy multiplication patterns side to side or up and down, so I am going to do cross products. 5 times L is 5L. And then I need to do 13 times 7, and that gives me 91. Then I have to get rid of this times 5. I do that by dividing by 5. So I do 91, and I divide by 5, and I get 18 2/10. And then my label is going to be yards. Labels are very important. Make sure you're paying attention to what they should be. All right, so let's think about if that makes sense. 13 and 5, and then I have 7. So here it's only a little bit bigger, that radius, so I would expect my slant height to get a little bit bigger too, which it did. So my answer makes sense. All right, go ahead and pause the video and try these two problems on your own. For number 2, you will need to do 2 different proportions, one for your length and one for your width. All right, let's go ahead and check our answer. For 1, cylinder D has a radius of 7.5 meters and a height of 4.5 meters. When I did example 1, I did the radius on the top. So I'm going to do the same thing here. Radius on the top, 7.5 divided by 4.5. And I get 1 6/10 repeating. So the other one that had that relationship was cylinder B. All right, number 2, the prisms at the right are similar. Find the missing width and length. Okay, so I need 2 proportions. Both of them need to have this 20/8, or the 20 and the 8 on there. Those 2 sides line up with each other. I think I'm going to go for the width first. So I'm going to do 20 over this 8 equals 8 over W. Okay, so I did height over width for the big, height over width for the small. Let's go ahead and solve it. So 20 times W would be 20W, and 8 times 8 would be 64. So I need to divide both sides by 20 to figure out what my width is. So if I do 64 and I divide by 20, I get 3 2/10. It did not say it around, so I'm going to leave it exactly that, 3 2/10 inches. That's my width. Now we're going to do the same thing, and we're going to find length. So I'm still going to start with my 20, but this time instead of doing 20 over 8, I'm going to do 20 over 11. And then I'm still going to start with 8 on this side, but instead of doing 8 over W, now I'm doing 8 over length. All right, and I'm going to solve this with cross products. 20 times L is 20L, 11 times 8 is 88. And then I am dividing both sides by 20. It's going to give me my length as 4 4/10 inches. All right, key idea, linear measures. Surface area of similar solids. When 2 solids are similar, the ratio of their surface area is equal to the square of the ratio of their corresponding linear measures. That's a lot of words. What that means is if I compare these 2 shapes, solid A and solid B, and I want to know how their surface area compares, I look at their linear measurements, a line on them. That line might be the radius, it might be the height, but it has to be the same measurement on both. So here it looks like A and B are the radius, or A is the radius on this one, B is the radius on this one. So if I want to know how the surface areas compare, I can take my 2 radii and I can square that, and it'll tell me the ratio of surface A to surface B. It's squared because area is in square units. So if this shape, if the sides are 2 times bigger, means my length is 2 times bigger and my width is also 2 times bigger. So the whole surface area is going to be whatever that number is, 2 squared. So let me show you what that means. That kind of sounds complicated, but actually once you know how to set up the proportion, it's not too bad. We just have to remember areas in square units. So when we write our proportion, we're going to use squared. All right, the pyramids are similar. What is the surface area of pyramid A? All right, so we're going to set up our proportion. We're going to take a look at the 2 numbers they give us for the dimensions, 6 and 10. I'm going to put pyramid A on the top, 6 on the top, 10 on the bottom. This is surface area, which is in square units. So my ratio needs to be squared. Okay, and then on this other side, I don't know pyramid A's surface area, so that's going to be X, but I do know pyramid B's surface area is 600. Okay, so I took the side lengths, I squared them because it's surface area. And then I have my surface area over here. I put pyramid A on the top. I put pyramid B on the bottom. All right, so my first step is to do this exponent. 6 squared is 6 times 6, that's 36. And then 10 squared, 10 times 10 is 100. Okay, and then I have x over 600. I see a multiplication pattern here, times 6. So I'm going to do 36 times 6, and that will tell me my answer. So 36 times 6 gives me 216. And then this is surface area. My units need to be squared, so feet squared. It's going to be my label. So I'm solving the proportions, same way we've done proportions all year long, but I have to do that squared part first before I start looking for cross products or multiplication patterns. All right. Let's go ahead and I'll get you set up on 3, and then you're going to try 3 and 4 on your own. So here the solids are similar. Find the surface area of the red solid. Round your answer to the nearest tenth. Okay, so for 3, I'm going to help you get set up. We're going to do, I'll do the blue shape first because I see it visually first. 8 on the top, 5 on the bottom. Okay, this is surface area, so that's going to be squared. I chose to put 8 on the top for my blue shape, so 608 needs to go on the top for the blue shape. They have to go on the same side of the proportion. I don't know what the surface area is, so that's going to be x. Okay. Go ahead and pause the video, finish problem number 3, and then try 4 on your own. All right, let's go ahead and check our answers. Next step on number 3 is to square our numbers. 8 times 8 is 64. 5 times 5 is 25. So I have 64 over 25 equals 608 over x. I don't see an easy multiplication pattern, side to side or up and down, so I'm going to do cross products on this one. 64 times x is 64x. And then I need to do 608 times 25. That gives me 15,200. And then I need to divide both sides by 64. All right, so when I divide, I get 237.5. Let's double check before I put my label in, make sure I have to round nearest tenth. Okay, so that already gave me an answer in the nearest tenth. I don't need to round it. Meters squared. All right, let's check our answers for number 4. Here they give me the diameter as my 2 side lengths to compare. My red shape is first visually, so I'm going to put it on the top side of my proportion. 5 over 4. This is a surface area problem, so it's going to need to be squared. Equals, I don't know what that surface area is. My blue one is 110. Okay, so I put my red shape on the top, my blue shape on the bottom. I need to square because it's surface area. Surface areas in square units. 5 squared is 5 times 5, that's 25. 4 squared, 4 times 4 is 16. Equals x over 110. I don't see easy multiplication patterns here, so we're going to do cross products again. 16 times x is 16x. And then I'm going to do 25 times 110. And I get 2,750. I'm going to divide both sides by 16. And when I do that, I get 171.875. This one I do need to round. 8 is the tenths place. The number after it, 7, tells me to round it up. So I'll have 171 and 9/10. This one is going to be centimeters square. And our last key idea is comparing with volume. Volumes, when we solve these problems, same thing as surface areas, except for now the ratio is equal to the cube of the ratio of the sides. Surface or volume is in cubic units, so when we set up a proportion, we need a cube as our exponent to the third power. All right, so let's go ahead and try that in a problem. The dimensions of a touch tank at an aquarium are doubled. What is the volume of the new touch tank? Okay, so the dimensions are doubled. We don't know. They didn't actually give us any dimensions. So we're just going to pretend, we'll make it easy, give ourselves small numbers. If this was the original and I said this was 1 foot on the side, and it was doubled on the new one, it would be 2 feet, twice as big. And then on this one with the 1, 2,000. And then we want to know the volume of the new one. All right, this is volume, so we're going to cube our ratio. All right, 1 to the third power means 1 times 1 times 1, which is 1. 2 to the third power means 2 times 2, which is 4, times another 2, which is 8. So I have 1 over 8 equals 2,000 over x. All right, if I do cross products here, 1 times x is x, and then 8 times 2,000 gives me 16,000. My unit is feet cubed, and it looks like that is option D. All right, here are 2 to try on your own. I will help you get the first one set up before I ask you to pause the video. So here, the solids are similar. Find the volume of the red solid. Round your answer to the nearest tenth. All right, so for these 2 cones, I'm going to put the first one first on the top. 5 over 12. This is a volume problem, so we're going to cube our ratio. 5, I don't know the volume. For 12, the volume is 288. All right, now go ahead and pause the video, finish problem number 5, and then do problem number 6. All right, let's go ahead and check our answers. Okay, so the first thing I need to do is actually cube this ratio. 5 to the third power, 5 times 5 is 25, times another 5 is 125. 12 to the third power means 12 times 12, that's 144, times another 12 is 1,728, equals x over 288. I don't see any easy multiplication patterns, so we're going to go ahead and do cross products. 1,728 x equals, and then when I do 125 times 288, I get 36,000. Then I'm going to divide by the number in front of the variable on this problem. That's 1,728. When I divide, I get x equals 20.83 repeating. Let's see, do we need to round? Yep, nearest tenth. So when I round to the nearest tenth, I get 20.8 centimeters cubed. It is volume, so we do need to make sure that is in cubic units. All right, let's go ahead and take a look at our next one. So here, I have side lengths of 3 and 4. I'm going to do my first shape on the top. 3 over 4. It's volume, so this is going to be cubed. Cubic units here, cubed here. Volume is 9. We don't know the volume on this one. So I did the blue on the top, 3 and 9. 3 and 9 on the top. Red on the bottom, 4, and I don't know. All right. 3 to the third power, 3 times 3 is 9, times 3 is 27. 4 to the third power, 4 times 4 is 16, times another 4 is 64. So I have 27 over 64 equals 9 over x. This one I do see a pattern. Divided by 3 on the top. So I can do 64 divided by 3 on the bottom to get my answer. It doesn't divide evenly. That's okay. 64 divided by 3 gives us 21.33. Repeating to the nearest tenth, that would be 21.3 inches cubed.